This video is going to cover Unit 22, Section 1, talking about triangles. A figure with more than 3 sides is not rigid. So let's take a look at some different pictures. You see on page 560, figure 22-1, 22-2, and 22-3. Okay? 22-1 is a triangle. That is a rigid figure. Now, figure 22-2 is not a triangle. So if you look at that figure, say you have some boards, so you go here, here, and you build this right here. Okay? It doesn't matter how strong these intersections are here. If you put pressure going this way, it will collapse, and it'll look more like what you see. Well, if you put pressure this way, it'll collapse like you see in 22-3. It'll collapse like this. So to keep it from doing that, you can put a cross member in there, and what you're doing there is you're creating 2 triangles. So if I push on it this way, that's going to try to make these 2 ends right here separate this direction like they did here, but this cross member will stop them from doing that. This cross member will hold these 2 points together and keep them from separating. If I put pressure on it this way, this cross member will keep these 2 points from coming together, like these 2 points came together. So a triangle makes a very rigid structure. Even if these joints are loose, a triangle will still be strong. A very good example of that you might be able to see in your own house is at the top of page 561 with the cross bridges between joints. If you go down into your basement, if you can see, you might see you've got joists going this way, all right? And then they're going to have flooring on top of them, like this right here. And then maybe you might have a beam or something in your basement going across them this way. Some kind of beam like that. Now, if you take and you put pressure down and to the side on this figure right here, you could get these things to fold over and look a little bit like, oh, I want to draw that, and look a little bit like this right here. They could fold over like that. It's going to have very good strength if you push down that way, but if you come at an angle, it's possible that they can fold over. Now what you see, I see them in my basement. There's cross members that come like this. They're just boards nailed in between the joists to make triangles. And that's what keeps them from shifting side to side. So a triangle is a very rigid figure, and it helps keep things straight. If you ever see people build shelves, so let's say you got the legs of a shelf here, and I'll just put 2 shelves on it for now. So you're looking at the shelves. Now, without anything backing that shelf can tip over very easily. And a lot of the shelves that you buy that are already pre-made from stores, they'll have, it's not very strong. It doesn't take a lot of strength to do it. So the ones that you get at the store will probably have like a really thick cardboard or a really thick paper backing that keeps them from twisting. If you've ever seen construction of a house where you've got, and this is all the same idea here, you have some kind of a strength from corner to corner. That's what you're looking at. So when you build a house and you've got the joists, or not the joists, but the studs, joists, You've got the studs coming like that, and you've got your base plate here, and then you've got this board above here. A lot of times they have a decent amount of strength while you're putting the construction up, but eventually what they do is they put OSB or plywood or some kind of wood over top of all that. And what that does is that holds the corners together to keep it from twisting side to side. And so those boards that they put on, those OSB boards, are what keeps your house from blowing over in the wind. Construction. All right, well, let's talk a little bit more in depth about triangles. At the bottom of page 561, we've got types of triangles. This is where we actually start the lesson. Equilateral triangles, we've got isosceles triangles, and we have scalene triangles. Now these are all different ways that we can name name a triangle by its sides. So we can name a triangle by the sides or by the angles or angle. Okay, so we have an equilateral triangle. We have an isosceles triangle. And we have a scalene triangle. These are all ways that we can name a triangle by its sides. Then we have 3 ways we can name a triangle by its angle. And now when we talk about the angle, what we're talking about is the largest angle of the triangle. All right? We could have an acute triangle. This has, well, let's get to that later. We could have an obtuse triangle. Or we could have a right triangle. Okay? Now, a scalene triangle is one where all the sides all are different lengths. So all are different. An isosceles triangle is where 2 of them are the same length. An equilateral triangle is where all are the same length. All the sides are the same length. An acute triangle is when we have the angle is less than 90 degrees. An obtuse triangle is when we have the angle is greater than 90 degrees. And then a right triangle is when we have the angle is equal to 90 degrees. So we have equilateral, isosceles, and scalene. Those are all based on the named because of the sides. And we have acute, obtuse, and right. And those are all named based on the angle. So an equilateral triangle is all of the sides are the same. So if I try to get one like that, something like that. Isosceles triangle is when 2 of them, at least, I should word it this way, at least 2 of them are the same. So it could look like this right here. Something like that. And then a scalene triangle is when they're all just different. Something like that. Okay, now, just to make it clear here, an equilateral triangle is also an isosceles triangle because it meets the definition. An equilateral triangle, all of these sides are the same. For an isosceles triangle, at least 2 of them are the same. So let's say this was 7, 7, and 7. So 2 of the sides of this triangle are the same. So this is technically an isosceles triangle, but it's more specific because all of the sides are the same. So this isosceles triangle over here, this side might be 10, this one might be 10, and this one could be 3, something like that. And of course, on a scalene, you may have a side here like 3, this one could be 7, and this one could be 9, something like that. Excuse me. So these are all addressing the triangles by their sides. Now, addressing them by the angle, an acute. So let's say you've got, let's see, that's 90. If I come just try to get it here. So as long as this main angle right here, the biggest angle, is less than 90, let's say this one is 80 degrees. This is an acute triangle. Now when we've got the biggest angle is more than 90, let's say this one's, I don't know, this looks like it might be close to 135. This would be an obtuse triangle. And then when you've got the largest angle is 90, and 90-degree angle should always, we've talked about this, that means that this side and this side are perpendicular. This is a 90-degree angle. You should always have this square in, if it is definitely a 90-degree angle, this tells everybody without question that this is a 90-degree angle. And this is a right triangle. Now these ones, the sides don't matter. All right? Now let's talk about this one right here. An equilateral triangle, not only are all the sides the same, but all of the angles will be the same as well. And all of the angles will be in every single equilateral triangle. As long as every side is the same, all of the angles will be 60 degrees. All of them. Okay? Now, with an isosceles triangle, there's some unique properties about an isosceles triangle, and also, those ones will also work on an equilateral triangle. On an isosceles triangle, if I draw a line from this top angle, this vertex angle, coming down to the center and splitting this base right here, that will always be a perpendicular angle right there, and this angle on an isosceles triangle will always be the same. Because this side and this side are the same, that means this angle and this angle will be the same. Scalene, anything can go. Any of the angles can be anything. So you can have an acute triangle that is a scalene. You can also have an acute triangle that is isosceles. All equilateral triangles will be acute because the biggest angle is going to be 60 because all of the angles are 60. So you cannot have an obtuse equilateral triangle or even a right equilateral triangle, only acute. But you could have an obtuse, I think I might have mentioned this, you can have an obtuse isosceles triangle, like for instance this one right here. If this side here is the same as that side, so let's say they're both 12, this is an obtuse triangle because of that angle right there. This is also an isosceles triangle because these two sides are the same. You can also have a right triangle that is an isosceles triangle and a right triangle that is a scalene as well. So a right triangle that's an isosceles could look something like this. Try to get that right there. Right there's the right angle. And this side would be the same, maybe 8 and 8. This is a right triangle, but it is also an isosceles triangle. And the rules apply. So that means this angle and this angle will be the same. So if I draw a perpendicular down from the vertex, that splits this side right here into two equal halves. Okay? So we have identifying a triangle by the sides and by the angle. You can do it either way. All right, so let's take a look at, there I go, erasing the whole page again. Did I knock that? Oh, let's take a look at page 563. Page 563. See here, 7, 8, 9. 9. Number 9, there are a bunch of different figures there. We are identifying these triangles by their sides. So you've got A through H right there. So C, for example, you've got one side is 8 foot and then another side is 8 foot. Right there, I don't need to really look anymore. I know that that is an isosceles triangle. But I'll look at the third side to make sure that it's not equilateral. So the third side is 6.5. So it is just an isosceles triangle. All right. Now you've got E, and all they're giving you there are angles. Okay. But we're supposed to identify it by its sides, but all they're giving us are angles. Well, let's examine this a little closer. One of the angles is 36. One of the angles is 85, and the other one's 59. Now, because all of those angles are different, the sides are all going to be different. Okay? So that makes that a scalene triangle. All right? So it is scalene. Let's take a look at G. It shows me that all of those angles are 60, but we're not identifying this by its angles, we're identifying this by its sides. And because all of those angles are the same, that means all of the sides will be the same. So therefore, that is an equilateral triangle. Now looking at F, once again, they're giving us angles only. But the two bottom angles, well, they're not really bottom, but the two of the angles are equal. 78 and 78. That means the opposite sides of those angles are the same as well. So that makes that an isosceles triangle. And because they're 78, I know it's just isosceles and not equilateral. And so if I look at H, I see one angle is 148 and the other two angles are both 16. Because those other two angles are the same, that means that their opposite sides are the same as well. Therefore, that is an isosceles triangle. All right? Now, I know that those ones are given angles, and we're asked to identify them by their sides, not by their angles. So we use their angles to help us figure out what the sides are. So the one triangle, E, all of those angles are different, so that means all of the sides are different. So that is what makes that a scalene. So looking at like D, we've got one side's 36, another side is 36, and the other one's 36. So all of the sides are the same, therefore that is an equilateral triangle. Now I know it's not asking, but we also know that all of those angles will be 60. And here's the reason why. Because in a triangle, all of the angles add up to be 180. If all three angles in an equilateral triangle are the same, that's just 180 divided by 3, which is 60. It means they're all the same. So B, every side is different. 6, 8, and 10, that makes that a scalene. All right? Now, let's go down to number 10, and let's identify some of these as obtuse or right or acute. A, clearly obtuse because the biggest angle is 91. Same thing with B, the biggest angle is 91. Because I'm only identifying these by their angles, B is also an isosceles triangle, but that's not what I'm interested in here. The reason why I know that is because the 44 degrees and 31 minutes is both of those other angles. Now, let's look at D. Is D acute, obtuse, or right? Well, the biggest angle in there is less than 90, so therefore that is an acute triangle. Now, it's also an equilateral triangle, but that's not what's important here. The fact that the biggest angle is acute. Now, F, because the biggest angle is 90, they did not put the triangle in here, but they still identified the angle being 90, so that is a right triangle. Let's take a look at C, okay? All right, so I see one angle is 66 and the other one's 24. So I don't know I probably could do that in my head, but let's find out. So what I'm going to do is I'm going to take 180 and I'm going to subtract 66, and then I'm going to subtract 24. And let's see what happens. That's 90. So that other angle is 90. So this is a right triangle. C is a right triangle.